Yes, there's supposed to be a lot of definitions on the screen. So when you're looking at the log, you read it log base b of x equals y. The inverse of the log is the exponential function. And these can be written back and forth. When we write these, I find it easy, just start with the base and loop around. B to this power equals this. So it just loops around. The same thing going back, log base b of x equals y. When there's no base, the base is 10. So a calculator uses base 10. If you were going to plug an a value in to solve, it needs to be base 10. Now, some calculators like the TI-84, in one of these, I think it's math, you can find different bases. But it's just easier to convert it than it is to try and look for them every time. Which I'll give you a change of base formula. The natural log is the ln. Y equals the ln of x, or the natural log of x. It's an inverse with e. So y equals the natural log of x. X and y would be the same values as e to the y equals x. They're inverses. There we go. These are all properties. When you have a base and you're taking the log of the same value, it's just 1. Or I usually don't use this. I just remember this one because log base b of b to the x is x. In this case, it's just a 1. The log of 1 is 0. The natural log of 1 is also 0. B to the log base b of x is x. You can think of these ones here like canceling. We use this one a lot. If you have m and n have to be positive. But if we have the log of m equal to the log of n, then m and n are equal, as long as you have the same base. In this case, it's base 10. So if we're solving an equation and there's a log on both sides, as long as it's the same base, we can drop the logs and set the two quantities equal. This one, when you're kind of think of this as like a distribution. The log of m times n is the log of m plus the log of n. So sometimes we'll break it up and go this way. Other times we'll want to combine them and go this way. Just like multiplication, division. When you're dividing, it becomes a subtraction. It's the top one minus the bottom one. So you always subtract the bottom. Log of m to the k. It can be any base. You can bring the k down in front, k log of m. The natural log and e are inverses. So you can think of them as canceling just like this canceled because they're inverses. and leaves x, and the natural log of 1 is 0. I think that there's any. These rules for logs, they're also natural log. So the natural log of m divided by n is the natural log of m minus the natural log of n. So whether it's a log or a natural log, the ln, these rules still apply. I'll give you a minute to get them written. When we're solving these, oh my gosh, I'm sorry. The biggest thing you need to be careful of is if your variables here, because you can't take the log of a negative number or 0. So you have to make sure that your answers are greater than 0. So if the variable is here for a log or natural log, you have to check your answers. Some will work and some will not. Okay, let's try some problems. So the first couple, we're going to just rewrite them. If we have log base 3 of x equals y, we want to rewrite it as an exponential. Make this a little smaller. I always put my log first because then I can start with the base and just loop around. 3 to the y equals x. So that was log base 5 of x equals 2y. So go ahead and rewrite it as an exponential. Start with the base and loop around. So it's 5 to the 2y equals x. Any questions on that? ln of 2. Now for the natural log, I think it's easier to just take e of both sides rather than trying to remember the formula that I had given you. If you take e of both sides, these cancel. 2x equals e to the y. Because the natural log and the exponential function are inverses. So when I have a natural log or an exponential, I just take the opposite one of both sides. Any questions on that? So if I had the natural log of x equals 3, I could solve this by taking the exponential of both sides, because this will cancel. X equals e to the 3rd. Number 4. This one doesn't have a base. What's the base? Anyone? When there's no base, yes, it's a base 10. So 10 to the y equals a negative x. Any questions on writing it exponential form? Okay, let's try number 5. 5, we're going the other way. Start with the base. So the log base 4 of x equals y. Loop around. So log base 4 of x equals y. Try number 6. Three to the p equals m. Start with the base and loop around. So you get log base 3 of m equals p. Any questions? Well, let's try 7. They just want you to rewrite it. So start with the base and loop around. Log base 2 of 5 equals 32. Any questions on 1 through 8?
Wait, for number 7, wouldn't it be log base 2
Yep.
of 3?
Thank you. I always write it the opposite. I knew I shouldn't have done that. I like to put my base first. So log base 2, and I still, sorry about that. 32 equals 5, yes. So the exponent becomes your answer. Any questions on that one? Evaluate the logs if possible. Round each answer to 3 decimal places. Okay. So if we look at the first one, when they're telling you these ones, it is not equal to a value, put it equal to something. So log of 7 equals x. Now this is one we could just plug into our calculator, because it's base 10. I think change of base, it must be in the next section. But we could plug this into our calculator. The log button is right here. So log of 7. You should be getting point, what did they say? 3 decimal places. 0.845. So this was 9A. These are just making sure you know where everything is in your calculator. The natural log of 86. The ln button, it's usually somewhere near your log button. ln 86. Oops. .454. Some calculators, there's a trig button, and then when you hit it, it has them across the top. Any questions on log and natural log? Notice the B, this one, log of -12. You should get an error because you cannot take the log of a negative number and you can't take the log of 0. So if we click to log -12, it's not a real solution. That also goes for natural log of -5. It's an error. Log of 0. Oops, wait. Log of 0. So if you do get an error, double check that you plugged it in right. But you cannot take the log of a negative number or 0. Any questions? So looking at number 11A. Now they want us to solve these without a calculator. Put it equal to a variable and rewrite it. So if we rewrite this, we'd have 2 to the x equals 32. Can we write 32 as 2 to a power? So first I rewrote it, 2 to the x equals 32. Now this can't go any smaller, but 32 is 2 to a power, because if I can have the same base, if you have a to the x equals a to the y, then x equals y. So if I can get the same base, I can set the exponents equal. I think it's 5, 2, 4, 8, 16, 32. So 32 is 2 to the 5th, which means x equals 5. Any questions? These are all going to be the same. But let's try C. Well, log 327. So rewrite it. Three to the x equals 27. Can we write 3? Can we write 27 in this 3? Three times 3 is 9 times 3 is 27. X equals Any questions on that? Okay, let's look at. Which one was it? 12B. Log base 9 of 27, and I'm gonna set it equal to a variable. So we'll rewrite it. Can 27 be written as 9 to a power? No. But we can make both of them 9 and 27 to the same base. Because 9 is 3 squared. 27 is 3 cubed. So sometimes you can't get it down to the same base. You may have to work with both of them to get them to the same base. And then an exponent to an exponent is multiplied. So whatever is already in an exponent, if you rewrite to get more exponent, they're multiplied together. An exponent to an exponent is multiplied. Any questions so far? We have the base the same, so 2x equals 3, and then divide by 2. Any questions on that? Okay, 12D. When you have the natural log and the exponential, they cancel each other. And it's 3. If we plug that into our calculator, ln's right here. And then for the exponential, it will always be with it. E to the x. So I hit second in the ln button and then put my 3. Close my parentheses. So think of them as canceling. Oh, 13's a good one. 13A. So first thing, rewrite it. Yes, but I'm not sure which one you mean, like this one. 12B. Okay, I'll go back to it. On this one, we rewrite it. 3 to the x equals 1 over 27. This time the 27's in the denominator. We know that 27, 3 times 3 is 9 times 3 is 27, is 3 cubed. But it's in the denominator. What do I have to do to move it up? Anyone? Yes, make the exponent negative. So here we have 3 to the x. When we move this up, it becomes 3 to the negative 3. it changes the sign on the exponent. And that means x equals a -3. Um, Okay, let's try this one. It will be similar to, well, B, I think it was, yeah. So first rewrite it. We can't write both of these, or write this one as 8 to a power, but we could write both of them as what value? What base could we use? Yes, we can write both of them as 2 to a power. So 8 is 2 cubed, and an exponent to an exponent is multiplied. And 16 is 2 to the 4th. So sometimes you have to change both of them. Now, if you can't change them, then we have to do something else that's in a different section. So for right now, you should be able to convert them both. Then we know that 3x equals 4, and divide by 3. X equals 4. Any questions on those? What's the next group? 31. 31 through, or is there any questions on these? We do a lot more in the next section. Okay. We'll go back if we have to. The rewriting ones are usually, once you see it, they're not hard at all. But what we're doing is we're using those rules I gave you. If it's multiplication, it becomes an addition. If it's division, it becomes a subtraction. Exponents can be brought down in front. That's what most of these will use. Okay, so let's look at number 31. The natural log 3x minus 2 over x plus 1. No, this is being, like, these terms have to go together. They have to stay together because they're addition and subtraction. You can't break the top and bottom apart. But we can write it as the natural log of 3x minus 2. And then this is in the bottom, so minus the natural log of x plus 1. But we can't break it any further because it has to be all one term to break it up. Let's look at 32. Log x cubed. Notice there's a multiplication here. You want to break this up first. And from our formulas, a multiplication becomes an addition. So it would be the log base 10, remember when there's no base, it's a 10, x cubed. Multiplication becomes an addition. And then log of 3x minus 4 to the 5th. Now we can take these exponents and put them down in front. So it's 3 log of x plus 5 log 3x minus 4. So when it's asking you to break them up into sums and differences, you want no more multiplications like this one and no exponents. $33 log base 3 the cubed root of 4x plus 1 over 4x squared. I usually, if there's radicals, I get rid of the radicals first. So a cubed root could be written to the 1/3 power. Four x plus 1 to the 1/3. So remember, a radical is a fractional exponent over 4x squared. The top one is added or positive. Log base 3 4x plus 1 to the 1/3. Now, if you want to write them apart and put the exponents down in front, that's up to you. This one, actually, because it's not in parentheses, only the x is squared and this is multiplied. So we could break it up right now. Log base 3 of 4 minus log base 3 of x squared. And then bring all your exponents in front. This one didn't have one. So I took the top and then I subtracted both parts of the bottom, minus log base 3 of 4 and minus log base 3 of x squared. And then any exponents, this one had a 1/3 and this one had a squared. Any questions on that one? Positive. $34 is the exact same. $35 is taking the ones that are broken up and bringing them together, writing them as a single logarithm. So we have 3 log base 2 of x plus before you can combine them, if there's a number in front, it needs to go to the exponent. So you're just working backwards. We put the number here, we move it back up. Log base 2 of x cubed plus log base 2 of y. Then the addition, I didn't have one right there. The addition becomes a multiplication. Log base 2 x cubed times y. Any questions on that one? $36. Log of x. Log of x minus 1/3 log y. So go ahead and combine that one. So first you move the 1/3 up to an exponent. And then this is a subtraction, so it becomes a division. The one that is negative goes on the bottom. Any questions on that? When we
So
have,
you can just keep it like that. You don't have to like put it in radical form.
I'm fine with it kept like this. I'm not sure what my math lab's gonna do. So you could, I would not take off if it was left here. But if they did put, let's see how they word it. It just says a single logarithm with which this is. But if they do, because this is in the denominator, it's a radical. It would be a cubed root of y. They should accept both of these because they are both a single logarithm. But I'm not sure what they, so if they don't take this, then rewrite it like this. On a test, I would accept both of them. I think what it might say is put your final answer without a fractional exponent. If you see something like that, then it means this. I think I have it with me. Okay, the one I have doesn't have a fractional exponent. So I didn't have to worry about it. And this one's breaking it up. I don't think you'll come across it, but on a test, I would accept either way. Try 37. Now, this exponent is the same as 2 to the 4th, a to the 4th. So this would be 16. So you have the natural log of 16 a to the fourth divided by the b. I would think that if you ran into something like this, they would want this definitely multiplied out. Any questions on those? $43. Number 43. Suppose that the supply of a product is given by P equals 20 plus 6 natural log of 2Q plus 1, where P is the price per unit and Q is the number of units supplied. What price will give a supply of 5,200 units? So Q is the number of units and 5,200 is units. So we're plugging that in for Q. So to find the price, we would just plug that into our calculator. $20 plus 6 natural log 2 times 5,200 plus 1 and close our parentheses. $75.50. So if we sell them for $75.50 each, we will sell 5,200. Is everyone getting the 75.50? The biggest thing, I know you know where it goes. The biggest thing is plugging it into the calculator correctly. Is everyone getting 75.5? Any questions on? We'll do the next one. Try 44. Suppose that the demand function for a product P is 500 divided by the natural log of Q plus 1. Excuse me. Where P is the price of the unit and Q is the number of units demanded. So I plugged it in 500 divided by the natural log 6,400 plus 1 and then closed my parenthesis. And I got $57.05. Any questions on that? Positive. Any questions on rewriting them? I don't like these other problems. Okay, let's look at one more, number 40. Looks interesting. Using the data for selected years from 1990 to projected 2050, the total US population can be modeled by Y equals a negative 363.3. Sure. On this one, someone asked to do another combined one. On this one, we're just plugging in 1950, the population at 2026 and 2023. The main thing I wanted to say was, remember, you don't put the year in. Take 2026 minus 1950. And plug it in. And when you subtract, you'd be plugging for the first one 76 in. So just be careful of that. When we have ones that are where you combine, okay. If we have the natural log of x squared plus the natural log okay. So if we have this and we want to combine it as one. First thing we do is move our values up. Now this one was already up, but the 3 can go up and the 1/2 can go up. So we'd have the natural log of x squared plus the natural log of y cubed minus the natural log of z plus 1 to the 1/2. And that can be rewritten. 1/2 as an exponent is a square root. But I'm going to wait and do that last. These two are added, so they get multiplied. So we have the natural log x squared y cubed. This one's a minus, so it goes in the denominator. Z plus 1 to the 1/2. And then you can leave it like that. Or rewrite the radical of z plus 1. I would accept both of these. Any questions on that? Okay. If you do not have any questions, I will see you on Friday where we will cover the last section.
We didn't cover anything from 27 to 30, did we?
No. Mm-mm.
Okay, I just want to make sure.
Yeah, this section's not really covered, but for some of the things we solve later, we need the part that I covered. So I don't cover everything since we don't need to. I only cover what you will need for the other parts.
Okay, thank you.
You're welcome.